Now, consider two parallel plate capacitors A and B. The plates of A are labeled P and R, while those of B are S and T. Let the capacitance of A be C1 and that of B be C2. The plate P is connected to the positive terminal of the battery, and plate R is connected to plate S of capacitor B. The plate T of B is connected to the negative terminal of the battery through a switch K. This is a series combination of capacitors A and B. Let a voltage V be applied by the battery. When the switch is closed, electrons are transferred from the plate P of capacitor A and onto plate T of capacitor B. A negative charge thus accumulates over the plate T. Let this charge be negative Q. An equal amount of positive charge plus Q accumulates on the plate P. As negative Q accumulates on plate T, an equal amount of negative charges are forced off plate S of capacitor B. Hence, the plate S has an excess positive charge which is equal to plus Q. The negative charge leaving plate S travels through the connecting wires and accumulates on plate R of capacitor A. Hence, the magnitude of electric charge accumulated on the capacitors connected in series is the same. Let the potential difference across capacitors A and B be V1 and V2 respectively. The relationship between capacitance of a capacitor C, the charge Q accumulated on it, and the potential difference V across its plates is given by Q is equal to CV. This means that Q is equal to C1 V1 for capacitor A, and Q is equal to C2 V2 for capacitor B. Simplifying these two expressions, we get V1 is equal to Q over C1, and V2 is equal to Q over C2. Recall that the total potential difference across any number of devices connected in series is the sum of the potential difference across the individual devices. Thus, V is equal to V1 plus V2. Taking C to be the equivalent capacitors of the series combination of capacitors, then we have charge Q is equal to CV. From this expression, we get V is equal to Q over C. Substituting equation 5, 2, and 3 in equation 4, we get Q over C is equal to Q over C1 plus Q over C2. Simplifying the expression, we get 1 over C is equal to 1 over C1 plus 1 over C2. Equation 6 gives the relationship between the equivalent capacitors for the combination of two capacitors connected in series and their individual capacitances. The equation can be extended for any number of capacitors with different capacitance values connected in series. If n number of capacitors with capacitances C1, C2, C3 all the way to Cn are connected in series, then the equivalent capacitance C is obtained from the expression 1 over C is equal to 1 over C1 plus 1 over C2 plus 1 over C3 all the way to plus 1 over Cn.